All right, finish one project, straight into the next. So I've got this roller compactor attachment for my skid steer, which kind of came apart. Well, not really came apart, it just sort of stopped working. This is a Ritchie Brothers special from China, of course. And while it worked great, but part of the design flaw was that they had a grease fitting that was buried way down inside that you couldn't actually get at to grease. And of course that meant that it didn't get greased. And that meant that the bearing completely failed. And when that happened, things went out of line. This sort of coupler here, this thing used to have like wings and rubber in there, which transferred the drive from the hydraulic motor to the eccentric shaft inside there. Well, that all disintegrated and started coming apart. So that's dead. And you think I could get new parts for that? Yeah, good luck. Anyway, that's what happens when you buy Chinese junk. You gotta rebuild it yourself. No problem, I'm working on it. So this coupler was an issue. However, I found this, which is a common drive coupler for things like drive shafts in cars. This one I think was listed on, I don't know, eBay or something for a compressor, Ingersoll Rand compressor of some sort. So anyway, it looks like the dimensions all line up, that all I'm gonna have to do is just bore out my bolt sizes for something a little bit larger, and it should bolt in place of what's here. Oh, I got a broken off, whoops, got a broken off, boy, I'm clumsy today, aren't I? Broken off bolt I gotta pull out of there. Anyway, separate part. The other thing was, this was the bearing that completely died. And oddly enough, it's not the one that the shaft runs on. It's the one that the drum rolls on, that connects basically the drum with the frame on the motor end of it here. And like that's like low speed. So this thing just like disintegrated like crazy. And it wore out the, nope, not that end, although that's a little worn too. Where is it? Oh, here, yeah, so here. This is the part of the drive assembly here. This is supposed to go together with this. There's supposed to be a bearing in between there, et cetera, et cetera. The bearing, when it spun, ended up galling up this shaft. So here I've started work on it and welded up the spindle. And I got to turn that down now. So that is what we're working on right now. I managed to secure, also for parts here, a decent quality bearing to replace it. That was fairly simple to come by. And somewhere around here I got a grease seal. I think it's over by the lathe. So anyway, that's this is step one here. Machine this down so that I can get a bearing back on there. So let's get the setup in the lathe and go to town on it. All right. So we got that bouncing around within a thou, and on the flange here, going this direction, I got it within 2. So that's looking pretty good for me. This is a low speed application, so I'm not too worried about getting it super, super deadly. But now we'll start turning down the weld buildup. We're at 2.840 basically, and shooting for 2.760 or whatever the metric equivalent of that is. Looks like it's cleaning up okay here. be good. Yeah, by the time we get the rest of that cleaned up, that should work out all right. Okay, continuing on the compactor project. Sorry I didn't take more video here. I kind of got ahead of myself, but I got that spindle turned down in the lathe so that the bearing fit nice. Nice little press fit on there. And then I just had to do a little cleanup on the, what do we want to call this, the hub part. So press the bearing into the hub, put the circlip on the back side of it, pressed it onto the spindle. Then I've got a circlip that goes on there to retain that bearing, and then a grease seal to go in there. I don't really like the design of this thing. I'm sure somebody could come up with a much better design for it, but it's, I don't know, not my thing. Why is there a grease seal on only one side and then nothing right here, right? Like the grease is just going to puke out of there and then fall into the drum. Fill up the drum with grease, I guess. I don't know. Whatever. Chinese stuff. Anyway. So. Yeah, the next steps, I'll install this and the grease seal. And then I think I can assemble the eccentric back in the barrel. So I will work on that next, I guess. All right, let's get her together. Okay, that's all back together. Got that assembled. The spindle barely comes through the grease seal. I'm whining more about what I don't like about this thing, unless you're supposed to install that grease seal backwards, but that's dumb. Anyways, is what it is. So that's the boring part. That was pretty basic. This is a little more complicated here. This was kind of like a Lovejoy connector kind of deal, except with cheesy aluminum bolt-on wings that did not last, especially once it ended up being metal on metal, once everything kind of fell apart. So anyway, trying to find that is like impossible. I'm getting zero support from manufacturer. No, not a manufacturer, distributor here. So anyway, solution, one of these things. It's like a driveline coupler. So I managed to find one that, like the bolt holes line up perfectly there. So that's exactly right. This is exactly the right size here, I believe. Nope, I'm gonna have to build some shims in there, but I can do that. And just drill these out to a slightly larger size, and then I got her. So I think this is gonna work really nice. Excited about that. So how am I gonna do this? Maybe turn a ring that'll press onto here and be the right inside diameter for that, but then I need some notches for these, it looks like. Anyway, I'll figure it out, and I'll bring it back once I got her all together. This is the nose that goes on the eccentric shaft here, down there, and it drops in through this side. No, other side. It comes in from the other side. No, it does go in through this side, so that drops through there. All right, let's continue working at this. I should have run the camera for this. Broken screw extraction here, and I used my left-hand drill bits on this one. I think it's the first time I've actually used my left-handers for this. Oh, nice that they worked so perfectly. I just drilled through with a slightly undersized hole. Get a clean hole through there, and then went in with a couple sizes up with a left-hander, and it bit and caught and just backed itself right on out of there, just like it's supposed to. Perfect. Awesome. Okay, on to the next step. All right, man, I got a plan here. So cleaned this up. This thing actually comes with these little dowel pin holes that happen to line up perfectly. Well, pretty darn close to perfectly, a little bit of a stretch. And so that's awesome. These I need to do like a bolt with a washer to retain that down. And I do have enough clearance for the head of the washer here and the bolt. Sorry, head of the bolt and the washer, I should say. So that will be great. That'll be coming through like so. So I just need to punch these out from 8 mil to 10 mil. So that's going to work awesome. On this end, I've got this gap here, and I'm not sure how that's supposed to go. Maybe you actually machine this as sort of a spider kind of deal. But I turned a ring that'll fit over top of that, and my diameter fits right in there. So that'll be perfect. So what I'm going to do is drill and tap this here straight through, and then I'll cut off 3 little segments that will fit between here, and that should work, I think. So I'll just make a couple little wings, and these I want to drill and tap for 10 mil, punch those out as well, just to give a little bit more strength. These things are set up for 6 mil, but they made them like 6.75, so they're super sloppy. And that's like a little solid chunk of aluminum going through there. Can you see that? So I think that'll work perfect. I'll just punch those out to 10 mil, get a nice tight fit for that, and everything will be much more snug than it was. All right, let's get to work. Okay, making progress. I have got my little spacers made, and those are set up now for a 10 mil bolt to go through here. I also bored this out a little bit so it fits a 10 mil bolt in through there. So that'll be awesome. Now I just got to drill and tap the center hub thing there for 10 mil from 6, and then same thing on that. This I obviously won't be able to use an actual hex head bolt there. I'll have to use a socket head cap screw to fit in that recess there, and I actually have to shave this a little bit here because it's a little bit too big to fit inside that hub that I've got there, but that's no problem. I'll just clearance that a little, probably with a grinder or something, shave away that rubber and aluminum there. And it'll be easy peasy, and then I got to make myself some little bushings there. Excuse me, to go out to 10 mil size there. So that should be fairly easy as well. So I'll get all that done here now, and I guess I'll start with drilling and tapping that sucker out to 10 mil. Okay, ready to go here. And I just took a, where's the thing there? So I put a bolt in the bottom of the thing there, knocked the head off it. So then I just screw this thing on. There we go. Screw that, oops, sorry. Align the camera there, get that set up, and I aligned that already with my back jaw of my device. Pop that down, and then just crank in, lock that down, and oh yeah, I'm in back here's there. I suppose I could do that with the by power here. Am I just spinning? She's coming out. There we go. And it's out of there. So simple as that. Nice, quick, easy way to align that and make sure I'm dead in line with that hole. So now I can just throw a drill bit in there, punch that out, and rethread it. Sweet. Let's get to it. All right. Well, I didn't get too far with that. That is hardened steel, I guess, for fitting over the shaft of the motor. So I'm going to have to hit that with some carbide. Let's see if we can find a carbide drill here somewhere. Well, working on hole number 2, bust the tap. Managed to get drilled through there, but this stuff is resilient material. I'll try and tap through. Okay, now I gotta try and get that out of there. Fun. Okay, I'm on my last hole here. I broke one of my taps twice. I wore out the other tap that I have. My quality of metric taps that I have is not great. So I am going to give up while I'm ahead. Wait for tomorrow morning, Monday morning when things open, and I'm gonna go get me a decent taper tap to replace that. So given up. So likewise, I won't even try to hit that until I've got that other tap. That'll make life a lot easier. I guess I could drill that out here while I'm waiting. Get it drilled out to size. So in the meantime, what am I going to do? Oh, I got to make those little sleeves for that. So I think I will find myself some material and work on that instead.